Hi guys, welcome to a new video under Math SL. This is the first video on the topic of quadratics, and we shall begin with questions that require you to analyze equations in factored form. I shall tackle the 4 questions on the screen in front of you, and I shall begin question 1 shortly. So the first question that we shall tackle came in paper 1, May 99, question 3. Kindly take a minute and attempt to solve, and the answer shall follow through shortly. So we are told that this diagram represents the graph of the function x minus p times x minus q, and we are required to write down the values of p and q. Of course, p and q are the values that would set the function to 0. So this is very important. P is the value that if I replace x with, the function would be 0. This is the idea of factors. So if I put p instead of this x right there, I would get a 0 because p minus p is 0. Similarly, if I put q instead of x, I would get a 0 here because q minus q equals 0. Hence, p and q are the values of x that would make my function equal to 0, would make f of x or y equal to 0. So what are these values? These values can be obtained from the graph, because we can look at the graph and determine where y is 0 and which values of x correspond to that. So y is 0 at this point and at this point, and the corresponding values of x are negative half and 2. Hence the values of p and q are negative half and 2. And to make sure that you have the signs written down correctly, I usually like to first express the intercepts as factors. So I know that the x-intercepts are negative half and 2 from the drawing. So I'm going to convert them into factors and then compare to this expression right there. So x minus negative half gives me x plus half. Similarly, x minus 2 gives me this factor right there. So I shall compare these two brackets to the two brackets on top. I have x minus 2 and x minus p. Hence 2 equals p. And next I have x minus q and x plus half. So q has to be negative half so that it becomes x plus half. Either way you solve, you shall get that p equals 2 and q equals negative half. Next, I'm required to find the x-coordinate of C, which is the minimum point in the parabola. So you should know that in any parabola, we have a property of symmetry. That means that if I draw a line down the middle of the parabola, I split the parabola into two identical parts. Hence, the distance between the minimum point and the x-intercept is the same for the right hand side and the left hand side. So the distance expressed by the blue line has to be the same as the distance expressed by the green line. So the x-coordinate of C, which is the point in the middle right there, has to lie halfway between negative half and 2. So we find the x-coordinate by averaging negative half and 2. Hence this equation right there, negative half plus 2 over 2. This is the average of the two numbers, and this gives us 0.75. So take a minute to copy the answer down if you will, and I shall begin the next question shortly. So the second question came in paper 1, May 2013, time zone 1, question 2. Kindly take a minute and attempt to solve, and the answer shall follow through shortly. So you are given the diagram below, which shows the graph of x minus 1 times x plus 3, and you are required to write down the x-intercepts of this graph. So again, we have already explained the relation between the factors and the x-intercepts. The x-intercepts are the values of x that would set the function to 0. They are the values of x for which y equals 0. And on the graph, they exist right there and right there. These are the values of x for which y is 0. So how do I obtain these values if I have the factors? Very simple. So what value of x would set this bracket to 0? Obviously 1. And what value of x would set this bracket to 0? Obviously negative 3. So the values of x that would set the function to 0 are 1 and negative 3. Because if either one of the brackets is equal to 0, then the total product shall be equal to 0. So if the first bracket is equal to 0 and the second bracket is equal to any number, the multiplication of the two brackets shall equal 0. Hence, if x equals 1, I shall get here 1 minus 1, which is 0, and 1 plus 3, which is 4. So 0 times 4 gives me 0. Hence, when x equals 1, the value of f of x is equal to 0, which is why 1 is one of the x-intercepts of my graph. Similarly, negative 3 is the other x-intercept of my graph. In B, we are required to find the coordinates of the vertex of the graph of f. So the vertex of the parabola is the minimum point or the maximum point of the parabola depending on the shape of the parabola. So in this parabola we have a minimum point, hence this is my vertex. And in the previous video we have outlined, in the previous problem, we have outlined that the vertex has to lie halfway between the two x-intercepts due to the symmetry of the parabola. So I shall get the average of the two x-intercepts in order to find the x-coordinate that corresponds to the vertex. So 1 plus negative 3 over 2 gives me negative 1. This tells me that my vertex lies at x equals negative 1. So the x value, the value on the x-axis, the x-coordinate of the vertex is negative 1. However, the question requires that we find both coordinates of the vertex of the graph. So getting the x-coordinate here is not enough. I need to find the y value of my vertex. So the value on the y-axis that corresponds to my vertex. I find this by simply plugging negative 1 into my equation instead of x. So negative 1 minus 1 and negative 1 plus 3 instead of x. This gives me negative 2 times 2, which gives me negative 4. Hence, my vertex exists at point negative 1 and negative 4. So take a minute to write this down if you will, and I shall begin the next question shortly. The third question came in paper 1, May 2008, time zone 2, question 2. Kindly take a minute and attempt to solve, and the answer shall follow through shortly. So you are given the equation of the graph x squared minus x minus 2, and you are required to find both x-intercepts. So as we said before, the x-intercepts are the values of x for which y equals 0. So we want to find the values of x that would make this value of f of x equal to 0. which in other words means that we're going to solve this equation equal to 0. Now this is a quadratic equation, so in order to solve this equation equal to 0, I need to factorize, and you can either do this manually or using the GDC, but for paper 1 of course you have to do it manually, and there are two ways to do this, either using the quadratic formula or using regular factorization. I've chosen to use regular factorization here because it's much quicker. This is a simple problem. So the two factors are x minus 2 and x plus 1. So the values of x that would make this expression equal to 0 are the values of x that would make the two brackets equal to 0. And since the first bracket is x minus 2, then if I put 2 instead of x, I would get 2 minus 2, which is 0. Hence 2 is one of my x-intercepts. For the second bracket, I have x plus 1. So if I put negative 1 instead of x, I would get negative 1 plus 1, which is 0. Hence negative 1 is also an x-intercept. So in question B, I'm required to find the x-coordinate of the vertex, and as we said before, the x-coordinate of the vertex is right there, and the x-coordinate is right there. It lies halfway between the x-coordinates of the two intercepts. So I just need to average the two x-intercepts, which I found in A. So 2 plus negative 1 divided by 2 gives me half. Hence, the x-coordinate of the vertex is half. So take a minute to write this down if you will, and I shall begin the fourth and final question shortly. So the fourth question that we shall solve came in paper 1, May 2010, time zone 1, question 1. Kindly take a minute and attempt to solve, and the answer shall follow through shortly. So we are given a graph that has the equation 8x minus 2x squared, and in A we are required to find the x-intercepts. As we said before, x-intercepts correspond to y equals 0 or f of x equals 0. So I shall solve this equation equal to 0. And in order to do that, I need to factorize this equation. So I shall take 2x as a common factor, and I get this equation right there. Hence the factors or the values of x that would make y equal to 0 are 4, because if I put 4 here, I get 4 minus 4, which is 0, or actually just 0, because 2x, if x is 0, then 2 multiplied by 0 would give me a 0. So if I put 0 here, I would also get a 0. Hence my two x-intercepts are 0 and 4. And of course, you can note that one of the x-intercepts is 0 from this point right there. And the other x-intercept we have found to be equal to 4. So next I'm required to write down the equation of the axis of symmetry. So the axis of symmetry is the line that splits the parabola in the middle into two equal parts that are identical copies of each other. So the axis of symmetry has to pass through the vertex, which is the minimum or the maximum point of the parabola, depending on the type of the parabola. So we know that the axis of symmetry is a vertical line passing through the vertex. This is very important. So we should know that a vertical line has the equation x equals something. We want to know what is x equal to, and this depends on the x-coordinate of the vertex. And we know that the x-coordinate of the vertex is obtained by averaging the two intercepts, because the vertex has to lie halfway between the x-intercepts. So 0 plus 4 over 2 gives me 2. So I know that the x-coordinate of this line is equal to 2. Hence, the equation of the vertical line passing through this point is x equals 2. This is the equation of the line. Bear in mind, this is not a value of variable x. This is equation of vertical line x equals 2. There is another way to solve this. We should know that the equation of the axis of symmetry in general is x equals negative b over 2a for a parabola that has equation ax squared plus bx plus c. So the a is the number that lies next to the x squared, which is negative 2 here. And the b is the number that lies next to the x, and b equals 8 here. And c is the third number that does not exist in this specific case, because in this parabola we do not have a standalone number. Hence, I have found the values of a and b. They are negative 2 and 8. I plug them into this equation. So minus 8 over 2 times negative 2, which is negative 4. So minus 8 over negative 4, we have two negatives, they cancel out, and 8 over 4 is 2. Hence, x equals 2. This is another way of finding the equation of the axis of symmetry. And you need to know both ways, because in other questions, only one of these two ways can be used. So here you can solve the question in two different ways, but in other questions you might need to resort to a specific one of these techniques, so you have to know both. Anyway, in double I we need to find the y coordinate of the vertex. I simply plug 2 into this equation right there, obtaining a y value of 8. So take a minute to write this down if you will, and this concludes the fourth question and the video, the first video on quadratics. I hope you have found it useful.